Yes. Okay. Now I need to share screen. Is it okay now? Can you see?
Yes, ma'am, it is recording.
Right. So as we said that this is a simple 4x4 grid. You know the rules of a Sudoku, right? So, so there are these 4 blocks and there are 16 cells. And let's say you just want to place the numbers 1, 2, 3, 4, right? So can someone quickly create a Sudoku like which satisfies the condition that 1, 2, 3, 4 occurs only once in every row, in every column, and in every block? So if someone has a solution, you can call it out to me and I'll write it. Is everybody clear with the problem? So we have this 4x4 grid. You need to fill in the numbers 1, 2, 3, 4 so that they occur only once in every row, in every column, and in every 2x2 grid block. So if someone wants to tell me the solution, you can tell me row wise and I'll just write the numbers like this.
Ma'am, I think I have a solution.
Yeah, please go. It's okay. Now, another thing is that don't worry, don't worry about being right or wrong. Just interact. Okay, it is a very,
okay,
yeah.
so
Tell me row wise. What are your
row wise?
Yeah.
First row, I think it will be 1, 2, 3, 4. I just
Okay.
1, 2, 3, 4.
Yeah.
Then
Second,
3, 4, 1, 2.
3, 4, 1, 2. Okay.
Then 2, 1, 4, 3.
2, 1, 4, 3.
Then 4, 3, 2, 1.
4, 3, 2, 1.
Yes.
So everyone else, is this a correct solution? I mean, does it satisfy the conditions that we need in a Sudoku? Everyone, others can comment yes, no.
Ma'am, I think it's correct.
Okay, who gave this solution? I'm sorry, I can't see you. So,
Manan.
huh?
Manan.
Manan. Okay, so this is Manan's solution. Okay. Okay. Anyone else? So let me. So now I want. So there are more possibilities. I would want a solution other than Manan's solution. Anyone who wants to attempt?
Ma'am, first row 1, 2, 3, 4.
Who's speaking?
Ma'am, Ayana.
Huh?
Ayana.
Can you spell your name, please?
Ayana.
I'm sorry, there's an echo, so I can't hear.
I'm saying Ayana.
Ayana. Okay.
Yeah.
Just tell me your spelling. A-Y-A-N-A?
AYAANA.
Yes, Ayana. Please tell me your solution row wise.
Ma'am, first row same 1, 2, 3, 4.
Okay.
Second row 3, 4, 1, 2. Third row 2, 3, 4, 1.
2, 3, 4, 1. Okay.
And fourth row 4, 1, 2, 3.
Great. This is also correct.
Yes.
But different from Anand's solution, right?
Yes.
Ma'am, can I answer the next one?
Yeah, please go ahead. Name, please.
Ma'am, Divit, D-I-V-I-T.
Okay. Go ahead.
Ma'am, it's 2134.
2134.
3421.
3421.
4312. 1243. 3. Yeah. Yes.
Wonderful. Okay, so anyone, maybe we can go with one more solution if Someone else has anything different from these three?
Ma'am, can I answer?
Yes. Who's the
Ma'am, my name is Vani,
Vani? Okay.
Vani.
Huh.
So the first row will be 1, 2, 3, 4.
Okay.
The second row will be 4, 3, 2, 1.
Hmm.
The third row will be 2, 4, 1, 3.
Hmm.
And the fourth row will be 3, 1, 4, 2.
Great. So we can all go on like this. I still have two more bits if anyone wants to, or we can now move on to the next part, which we really want to address. Anyone who quickly wants to share a fifth solution?
I came up something that was exactly similar to Manan's. So
Okay. Anyone with anything different from these four?
Ma'am, I have one. Ma'am, this is Hemang.
Yeah. Yes. Go ahead.
Ma'am, 3214
3, 2, 1, 4. Yeah.
4132
Hmm.
2341 1423.
By the way, did you guys ever really try 4 by 4 Sudokus before?
not before. No, this was first time for me at least.
Yes, even for me.
Okay. Actually, we are just filling in a grid so that it satisfies the Sudoku conditions. But in a regular Sudoku, you would get some numbers filled already,
Filled in.
and
You'd
you
have
have to
to
complete,
record it.
right? So now my question is: suppose you want to create, you are a developer of Sudokus, right? So you would obviously like to have a set of all possible solutions of this 4 by 4 grid, and then you would you would suppose, like the newspaper is presenting one Sudoku every day, right? So they show some values. So suppose you create a Sudoku, right?
Sunaki ma'am, I'm sorry to interrupt in between. There's a student waiting to be entered, Atharv. If you can admit him, you just sent a message.
Okay. All right. Now when I get out of this screen, unfortunately, I'll lose all this text. So can you, you all have noted this down, right? All of you have these 5 solutions.
Ma'am, we can take a screenshot of it and
You can take a screenshot. Yes, yes. I'll just let the person in. So let me see. Which is why it is better to have someone else. So let me see who's, yeah. Right. Okay, so I think now it's okay. Right. Yeah. So we filled in that, we had 5 distinct solutions, but I want to know what we want to do is count as to how many solutions are there in a 4 by 4. How many such solutions are possible? We listed out, you gave me 5 different solutions. Okay. For those who have just walked in right now, we are trying to see the number of ways of filling this 4 by 4 grid using the numbers 1, 2, 3, 4. So it's, imagine that this is a 4 by 4 Sudoku. So we need to fill in the numbers 1, 2, 3, 4 such that 1, 2, 3, 4 occurs only once in every row, in every column, and in every 2 by 2 block. And the same is true, in a regular 9 by 9 Sudoku, you have 9 rows and 9 columns and 9 blocks. Here you have 4 rows and 4 columns and 4 blocks. So anyone quickly wants to give me a 6th solution? So that just for the benefit of the people who have just come in. Maybe we are kind of running out of solutions now, right? Even teachers, please, you're welcome to. I mean, this is.
Ma'am, honestly, we can have many solutions, because there are a lot of combination of numbers in 4-digit when we have 1,
So,
2, 3, 4.
who's speaking?
Ma'am, Manan.
Manan. Manan.
They will
Did
be
you-
similar. They will be similar, but we can always make one change in one row or
हाँ, तो
something.
आप एक और बताइए मुझे. आपने एक पहले you gave me the first solution. Do you have
Yes.
another one?
Ma'am, I'll make one quickly.
हाँ.
Ma'am, I have one solution.
हाँ,
Should I
Abhishek.
share?
Yes, Abhishek. Tell me.
It's 1, 2, 3, 4.
1, 2, 3, 4. Yeah.
2, 2, 1, 4, 3.
Is this possible?
I checked, maybe it is 2, 1, 4, 3.
No, in the block you can't repeat the numbers, no?
Okay, then my solution isn't validated.
Yeah. So you have to ensure that in every block 1, 2, 3, 4 occurs only one. So all the 5 solutions we saw earlier had satisfied that condition, right?
Okay, yeah.
Okay.
Ma'am, I made a new one.
हाँ, बोलो.
4, 1, 3, 2.
So I'm starting here, huh? 4, 1, 3, 2.
2, 3, 1, 4. Wait, I think it has been repeated before on one of the previous.
Doesn't matter. एक बार बोल दो.
2, 3, 1, 4. 3, 2, 4, 1. And 4, 3, 2, 1. Sorry, no. 1, 4, 2, 3. 1, 4, 2, 3.
Because you can't repeat 4 here. So 1, 4,
2, 3.
2, 3. Now let's check. Every row has 1, 2, 3, 4 occurring once. Every column has 1, 2, 3, 4 occurring once. Every block has 1, 2, 3, 4 occurring once. So yes, this is a correct solution. Anyway, so now by now we know how to list out, how to create it. It's not difficult. In a 9 by 9, certainly it would be harder, right? So now, could you tell me, now we need to start solving the actual question, and that is how many distinct solutions can we find for such a grid? So we need to count now. What are the possible number of solutions we can have? So for that, what I will do is I'll rub out these solutions.
Janaki, I'm sorry to interrupt. There's
Yeah.
still one more child waiting.
Oh, okay. I'm just a little confused. If I made you the host, would I still be able to share? There's maybe a problem with the sharing, so I don't know.
No,
You can if Seema ma'am allows you to, because there are some settings for the host to change for others also. So like if she allows in the settings to screen share for attendees, then you can screen share.
I think the best thing right now, Dr. Ghosh, would be just disable the waiting room. So that would be good.
Yeah, just give me a minute. Again, I'll stop the sharing and go to the participants. Are we expecting more people to join?
No, I think they were there. I think they got logged out maybe because of connectivity issues.
Oh, I see.
Because, yeah.
And some teachers might be walking out and walking in, no? So I think if the waiting room is disabled, that would be a good option.
Okay, how do I do that? See,
you would have to.
That's the problem. This doesn't usually happen in Zoom. I don't know why this is happening. So how do I you want me to disable it, right?
Yeah, disable the, like from the settings, you would have to go
enable waiting room. I just untick that, right?
Yeah.
But then I hope nobody else will get logged out, and we'll see.
Yeah, no, nobody will do that.
No, it's okay. These are all expected things, we have to factor in for now. I need to find.
Hi, Lona. I logged out like 2 minutes ago because I ran out of battery. Yes. Easy schoolboy error, but still I think the laptop won't run out anytime soon.
Oh no, now how do I get back? What's happening here? Let me do screen sharing again. Yeah. So coming back to the question, now we need to start thinking, how are we going to count the total number of possible solutions? Anyone has a suggestion for how we can do that?
Ma'am, I have a suggestion for it.
Yeah, please.
Ma'am, see, if you look at it in the top row, can you just write this down? I'm using it as an example. The 1 can be in either square. The first one, the second one, yeah. So let's just take a number. Yeah, so number 1, let's just say we put it on every square of the first row. Now we know the number 1 can be on 4 squares in the top row. That means every number in the top row has 4 possible positions, right? So in that way, right? So the 1 can be in the corner, left corner, right corner, and the right middle, left middle. So can 2, so can 3, so can 4, right? So that'll be that will be 4 positions possible times 4, right? So that will be 16. So that means there are 16 actually like possible different ways in which the numbers can be arranged if you think of it.
In the entire thing?
Not the entire thing, only one row. Yeah, I'm topmost row. So it's the same thing can be done for middle. The same thing can be done for the bottom row, right? Because every row in itself is an individual thing, right? So that way we know that there are 16 different ways in that one row we can have 1, 2, 3, 4 arranged. So in that, that's like one thing I figured out, and I have a feeling that might be useful.
On the top row,
yeah. Okay. It can be used for any horizontal row. Vertical, I'm not sure. I'm pretty sure vertical would.
Yeah, but then okay. So see, let's go again with the first row. Now instead of looking at number wise, shall we look at cell wise? How many ways can you fill the first cell?
4 ways.
4 ways.
4
1,
ways.
2, 3, and 4.
So when I write 4 with a circle, it means number of ways of filling, not the number 4 in the cell, but the way circled 4 means the number of ways of filling the first cell. Because you can put anything in the first cell, no? You can put 1, 2, 3, or 4. So there are 4 ways of filling the first cell.
Yeah.
What happens here? How many ways are there of filling the second cell?
3.
Why 3? Because you've used up one of the numbers here, you can't repeat it here. So there would be 3 ways of filling. Very good. Next.
2.
You've exhausted 2 numbers here. So there are only 2 left. So there are only 2 ways of filling this cell. And the last one, you're forced
only
to
one. You've exhausted all the rest.
Whatever is left. So what would be the total number of ways of filling the first row?
24. 24.
Absolutely, very good. Principle of multiplication. So 4 ways of filling the first cell, 3 ways of filling the second cell. Multiplied, we don't add, we can't add, we have to multiply. Because for every 4 ways of filling the first cell, there are 3 ways of filling the second one. And then thereby 2 of filling the third one, and finally only 1 way of filling the fourth one. I hope this idea is clear to everybody. If not, then please ask me to repeat. So these circled numbers are not the number to be filled in the Sudoku. By the way, in a Sudoku, you don't necessarily have to have numbers, right? You can have symbols, you can use your emojis, whatever you like, as long as there are 4 distinct symbols, right? Anyway, so here we are using 1, 2, 3 first numbers. So there are 4 ways of filling this, 3 ways this. So there would be 24, 4 into 3 into 2, 4 into 3 into 2 into 1 ways of filling the first row, right? And that, are you familiar with the factorial notation?
Yes, ma'am.
So 4 factorial basically means...
Ma'am, yeah, sorry, you continue, sorry.
Yeah, 4 into 3. So basically, what would be 6 factorial? I mean, I'm just asking what is 6 factorial?
Ma'am, basically, if I'm not mistaken, factorial means like that number multiplied with itself that many times. That's why like 2 factorial will, if I'm like 2 factorial should be like 4. I'm not, well, no, wait.
No, 4 factorial means it's 4 into, so you start with a given number and you take the continued product till you reach 1. Right? So 6 factorial would mean 6 into 5 into 4 into 3. So 100 factorial would mean what?
100 into 99 into 98 into 97 all the way till 1.
So why do we use this? This is because it just makes our notation convenient, writing convenient. Of course, there are many other properties of factorial, but we are not getting into that. So let's just ignore this for now. So 4 factorial, or 4 into 3 into 2 into 1, whose value is actually 24, is the number of ways of filling the first row, right? Okay. And that would be the same. So now, but then once there are 24 ways of filling the first row, but there are conditions, no, on what you can put in the second row. Because whatever number you've used up here and here, you can't use those two numbers here, isn't it? Suppose I put a 1 here and a 2 here, I can't use 1 and 2 here. So there are conditions on that as well. So definitely the number of solutions, the total number of possible ways of filling this grid, which is what the question is, or what we are exploring, is going to be much more than 24. So, but this is a good step to start with. This is a good step to start with. Okay. Another way of looking at this could be, let's come to this, this grid, suppose. Now, if I look at a block, how many ways are there of filling the first cell here? I'm now looking at
4.
this
block. So one will be 4, another will be 3, another will be 2, another will be 1.
यहाँ पे 2, maybe so 4 ways of filling this, 3 ways of filling this, 2 ways of filling. Again 4 into 3 into 2. So number of ways of filling up this block is again 4 factorial, which is 24 ways, right? So we can start with either a row. Same thing would happen for even a column. If I looked at the first column, why first column? Look at any column. Let's look at the second column. And how many ways of filling the first cell here? 4. Here 3. Here 2. Here 1. What I'm trying to say is, whether you start with a row or a column or a block, first that is a starting point. The number of ways of filling either a row or a column or a block will always be 24. Having said that, how do we further go ahead and count the total number of solutions? Okay, that's the next step. Okay. Now come to the situation, now come to this grid where I'm placing the numbers 1, 2, 3, 4. Okay. This is what, now I'm seeing that suppose I fix the positions of these numbers 1, 2, 3, 4 in the first block. I'm going blockwise. So I'm using this approach. By this approach, I mean I know that there are 24 ways of filling the first block, but I'm taking one of those 24 ways, and that is 1, 2, 3. Okay. Now tell me, what are the conditions? In how many ways? So this block can be filled up in 24 different ways, and I have only taken up one of them, just for this present grid. How many ways can I fill up these two ways? So it's 6. 1, 2, 3, 4, I have fixed in the first block. Now we have to see what are the number of ways of filling up the other cells in this block. Okay. So what are the number of ways of filling these? Let's take these two cells. Or we can even take these two, the column now. But let's take this.
Ma'am, there'll be 2 ways of filling the first block and then the one that's left.
2 ways of filling this cell, right? Because I've already used the 1 and 2 here. So in this case, we either have a 3 or a 4. So there are 2 ways of filling this cell. Having, suppose I put a 4 here, then I have to put a 3 here. Or if I put a 3 here, I have to put a 4 here. So there are only 2 possible ways of filling these two cells, right? So there are 2 ways of filling up these two. So does everyone agree? I'm saying, yeah. Let's take this as a fix. I have fixed the values of these 4 numbers. What are the number of ways of filling these two? It has to be 2 ways. It can either be 3, 4 or it can be 4, 3. Do you all agree with me?
Yes, ma'am.
Okay. What about these two? How many ways of filling these two cells?
2 ways.
2 ways. 1 and 3 hai already. Either I have a 2 and a 4 or a 4 and a 3. satisfies my Sudoku condition. So number of ways of filling these two cells will also be 2. And these two don't impact each other as such. Okay. So for every 24 ways of filling this block, I have 2 ways of filling these 2 cells and 2 ways of filling these 2. Okay. Okay. So let me now proceed from here and say these are my fixed cells. Let's say I fix 3, 4 here. Out of these 2 possibilities, I'm fixing a 3 and a 4 here. And out of these 2 possibilities, let's say I fix a 2 and a 4. Right? So, in a way, this is, there are 4 possibilities. No? I can put 3, 4 here or a 4, 3 here, and then I can put a 2, 4 here or 4. So, totally, there are 4 possibilities. Out of that, I've just taken 1 case. I put 3, 4 here and 2, 4 here. Now tell me, what else can I count? Of course, there have to be values in all these cells. But is there something which will help me count the total number of solutions? So far, I have come to the point where I can say that there are 24 ways of filling the first block, 2 ways of filling these 2 cells, 2 ways of filling these 2 cells. The total number of solutions is 20 till now. So 24 multiplied by 2 multiplied by 2. So 24 into 4. But there will be other ways also. So now tell me, is there any other cell using which we can count? First of all, okay, can you tell me what should come in this cell? Given these number positions, what should come in this?
Ma'am, it has to be either 1 or 4.
Okay. Why so? We can't have a 2 here because 2 is there in
Yes.
this row.
And 3.
We can't
I can't have a 3 because it's the row.
It has to be 1 or 4. Can it be 1? Let's try 1. यहाँ 1 डाल के देख लेते हैं. अगर यहाँ 1 डाला तो क्या होगा? आगे can you just quickly fill up the rest of the cells?
Ma'am, it can't be 1.
It can't be 1.
Right. You said it should be 1 or 4. Why can't it be 1 now?
Ma'am, it should be 4 only.
That location is only for 4 because it can't be in any other place in the whole box because because the vertical row there is already a 4, so
Yes,
it can't
there's
be,
already a
and the
4.
bottom row there's the 4, and all 3 locations excluding this one box, those 2 rows clash them, so you can't repeat
So if
the
you
number.
put 1, you will come to a contradiction somewhere, no? If you continue to fill using 1, isn't it?
That location, ma'am, is for 4, so that's cell.
So everyone agrees that you have to place a 4 here.
Yes.
Yes, ma'am.
Okay. So this is fixed. ये कुछ नहीं कर सकते. It has to, if 1, 2, 3, 4 are here, then 4 has to be here. Okay. Had it been some other combination here, maybe some other number. But for 1, 2, 3, 4, I need to have a 4 here. Very good. Achha, ठीक है. So this doesn't add to my count. So far, what is my count? From here, I can say the total number of solutions is 24 into 2 into 2
96.
into something. Maybe something further.
Yeah. In that box, currently there are 96. This doesn't help that.
In which box?
Ma'am, the top
overall
right.
grade. Yes. So there are possibly more than 96 possible solutions, right? अब ये देखो यहाँ पे तो 4 ticks हैं. Okay. What can I place here? In this set, what number can I place here? Can I place a 1 here? चलो ट्राई करते हैं 1 डाल के. यहाँ पे 4 है, यहाँ पे 1 है, तो यहाँ पे क्या आना चाहिए? Can you help me fill up the other number? हाँ बोलो.
Ma'am, for which
Actually, I'm
cell?
just looking. The locations for most numbers are fixed because the 4 has to be there, and the 1 does also, I believe, because there's no other choice. Because in the other.
Acha. Okay, let's just try complete the.
I think Manan was talking. Manan was saying something. I think I cut him.
Manan.
I was just asking what was the question. I mean, there was a long pause.
The question was that given these positions of numbers, and we decided that 4 has to be here in this cell, right? Now I'm trying to see what possibilities are there for this cell. If I place a 1, can I complete the Sudoku? Can you help me fill the numbers here so that this is complete with 1 in this corner cell?
Maybe yes, we can. I think we can.
Bolo. Everybody work on this and see if you can.
Excuse me, ma'am.
Yeah.
Ma'am, there's a glitch sound from your background.
Is it very loud?
It's not that loud, but yeah.
Okay. But am I audible?
Yes, ma'am, you are audible.
I don't know where the sound is coming from better. Has it just started coming or was it there throughout?
No, ma'am, only for a minute or two.
Okay.
Whenever you talk, there's a slight sound of crackling.
Yes.
Should mute themselves.
Okay. If it's too problematic, then I may have to take out my headphone.
Maybe yes, because I think it's the mic. It's the mic that is doing it.
Ma'am, it was fine before it just started coming.
Yes, it started.
Okay, let me know if this continues, and I will take off the headphones altogether. But then you might be privy to other noises from my background. And let's just go on with the mathematics. And, yeah.
Ma'am, this cannot be possible.
I think I got a solution. I think I got.
It can be possible.
It can be possible. I got a solution.
बताओ.
Yes,
Second row का क्या है?
Second row 3 4 1 2.
हाँ.
Third row 2 1 4 3. And 4 3 2 1.
This is definitely a solution.
Satisfies.
Yeah. Okay. 1 2 3 4 6 हाँ. 3 4 we decided to choose here. 2 4 we decided to choose here. We decided that 4 has to be here. Can I place a 2 here now? 2 3. This is 6. I'm trying to see what are the possibilities for this cell. Of course, I could have done it for any other cell, but the corner cell is sometimes obviously corner cell में
Oh,
तो
ma'am, I don't think you can place a 2 there.
No, 4 तो नहीं आ सकता ना यहाँ पे, because obviously 4 is here and 4 is here. 1 से तो solution मिल गया, अब 2 से नहीं मिल रहा.
Ma'am, I think I'm getting the 2 also.
Tell me the row.
Ma'am, second row 3 4 2 1. Then third row 2 1 4 3. And 4 3 1 2.
This is possible.
Yes.
Oh, wonderful. So corner cell में 1 भी आ सकता है, 2 भी आ सकता है, 3 आ सकता है.
Yes, ma'am, I've already found a solution for that.
For 3 also. Okay, great.
Yes, ma'am.
So so there are now 3 ways of filling up this cell. Given that 1 2 3 4 is in the first. Is the sound still coming, children?
Yes, ma'am, there is
Yes,
still
ma'am, whenever you speak, it does come.
Yes, ma'am.
Is it better now?
Yes, ma'am.
Yes, now it is.
There.
Oh, 1 second. Am I audible clearly?
Yes.
अच्छा,
Yes,
एक बार और try कर लेते हैं.
Ma'am, it again.
There again.
Now tell me, is that again?
Yes, ma'am, it started again.
It started again.
Let's do away with all this. All right. So, so now we said that there are 3 ways of filling this cell. So given 1, 2, 3, 4, that is one particular solution, remember that the number of ways of filling up this block was how much?
24.
24 different
24 ways of filling the first block. There were 2 ways of filling these two, 2 ways of filling these two, and further, there are 3 ways of filling up this. So the total number of solutions, of course, once you've put a number here, the rest of the values are unique. Am I right?
Yes, then you put a value there and then everything else fixes it.
So if you place a number here, then all these numbers are unique for that particular position. Similarly, when you place 2 here, then the remaining numbers were unique. So the other cells are not adding to more solutions. So what is deciding the total number of possible solutions is number of ways of filling the first block, the number of ways of filling these two, number of ways of filling these two, and the number of ways of filling this corner cell. So can you now tell me what is the total number of solutions? So it's 24 into 2 into 2 into 3 into 3. So how much is that? Yes? What's the product?
288. Oh,
I can't hear you guys clearly.
I think
288.
It's 288.
288, absolutely. 280.
288.
Vani, sorry, I lost your sound, became very muffled. So
she also said 280.
280, right? Okay, so yes. So what we did was our strategy of counting. So we were not filling up Sudoku, but in the process we did fill up Sudokus, right? So what we were discussing were that if I fix the position of the first, the numbers in the first block, then there are 2 ways of filling these two, 2 ways of filling these two. And we found that with the choice of 1, 2, 3, 4, ये जो number यहाँ पे fixed है 4, but I can place a 1 in this corner cell, I can place a 2 also, I can place a 3 also, I'll get 3 different Sudokus. And these cells, suppose I place a 1 here, these cells are unique. So they don't contribute to new solutions. So this is your final answer. This is you could say this is a problem in counting, or later on in higher mathematics, when you go to higher classes, you will be studying what is called combinatorics. So combinatorics is the art of counting without counting actually. So we didn't list out all the 288 solutions, did we? We started seeing certain patterns in the counting, right? So here this sort of summarizes what we've discussed. The number of ways of filling the first block is this block is 24. So this 1, 2, 3, 4 is just one of those 24 solutions. Now if I change this to say 3, 4, 1, 2, then I will get a different set of solutions, right? So there are 24, that is 4 factorial ways of filling the first block. So 4 factorial ways of filling up this block, 2 factorial or 2 ways of filling up this, 2 factorial or 2 ways of filling this, and 3 ways of filling up this cell. Number of ways of filling the rightmost corner cell is 3, and the total product is 288, right? So, using Sudoku, you can explore many other challenges as far as Sudoku is concerned. So now one little exercise for you to be is to, suppose you want to make a Sudoku for somebody. You have now, you are privy to all those 288 solutions, and you can create those solutions, right? So you know that there are 288 ways of filling this 4x4 grid. But if you want to give a Sudoku challenge to somebody with the minimum values, minimum positions of elements, what is that minimum number you would like to choose? And you can create a Sudoku puzzle for yourself. And that's what these newspaper people are actually doing, except that they're doing it with 9x9 grids, right? And who knows when will they run out of Sudokus? because that number, the total number of ways of filling a 9 by 9 grid is completely huge. So I guess they'll never really run out of, Sudoku challenges. Okay, shall we move to the next problem? I hope you enjoyed. This was meant to be like a warm-up.
Yes, I personally did enjoy it.
Okay. I'll be sharing the slides with you, so don't worry about, okay. Shall we move to the next one?
Yes.
Yes, ma'am.
Okay, let's see. There's one on magic triangles. Would you like to, we'll come to that. Would you like to try the chessboard one? Let's try this. This is also another problem in counting. So first, we're not going to play chess here. We just have an 8 by 8 chessboard grid. And the first question here is, how many squares of all possible dimensions are there on this chessboard? First, we will ask the question of squares, and then maybe we'll move on to the rectangles. Okay. So when you look at the chessboard, what is the first thing that comes to your mind in terms of squares? How many squares there are?
Ma'am, 64.
64 single squares, right? Black and white squares together.
Yes, ma'am.
Yeah, very good. But when it says how many squares of all possible dimensions, what do they mean by this phrase, all possible dimensions? So when you said there are 64 squares, small squares, what dimension do those squares have?
1 by 1 unit.
Yes, because original chessboard is 8 by 8, let's say, right? We can say this, if we treat this as 1 unit, then this original chessboard is 8 by 8. That's why they're using the 8 by 8 term. Okay. But you said 1 by 1 means single squares. So there are 64 of these. Okay. So let's say there are 64 of these. What other dimensions can we have?
2 by 2.
2 by 2.
3 by 3.
2 by 2. Okay. So let's say
4 by 4.
Okay. This is a 2 by 2 square within the chessboard.
Yes, ma'am.
So ऐसे कितने हैं? How many such 2 by 2 squares can I find on this chessboard?
I'm 16.
16?
Yes, ma'am, 16.
Okay. Everyone agrees?
Yes, ma'am.
So where will be the where will be the next square then? So this is one square. Which is the next one?
And the one right next to it.
This one?
Yes, ma'am.
Okay. And then next is this one. Then this one, right? Am I going the right way?
Yes, ma'am.
They're all 2 by 2 squares. But how about this one? Is this not a 2 by 2 square?
I don't think we can count the actual number of squares because there can be a lot of combinations.
So we need to count all those combinations. So in the first 2 rows of the chessboard, how many 2 by 2 squares can you see? If I just restrict myself to the top 2 rows, just these 2 rows.
8.
8.
8. Can you count again carefully?
I'm 7.
7.
7, 8, 4. Which is the correct one?
Ma'am, 7.
7.
Sure.
Ma'am, I think it
अच्छा ठीक है.
should be 7.
Just a minute. Let me go again. Let's mark out those 7. Okay? 7 or whatever. So first square would be this one. Right? Next is this one. 2. Then 3. 4. 5. 6, and 7. Am I right? So there's 7. So these are overlapping squares, definitely. But we have to take care of those overlaps also. If we don't count those, then we're missing out many. So from the first 2 rows of the chessboard, I can get 7 2 by 2 squares. How do I continue that counting process? Next, where will I find the squares? 2 by 2 squares, how will I count? So 1 by 1, you told me there are 64, and we are still counting 2 by 2 squares. Top 2 rows gave me 7. Now where do I go? Which next strip will I look at?
From the second and third, we can make squares.
Ma'am, it's a chessboard, so yeah.
Very good. So from the second and third row, again, I will get another 7. Now I'm
Then
not
third and fourth.
I know, right? So totally, can you tell me how many will I get?
Ma'am, 49.
Why? Because there are 7 such pairings possible. 1, 2, 3, 4, 5, 6, 7. There's 7 strips possible, and each strip is going to give me 7 squares. 7 2 by 2 squares. So it is 7 into 7, which is 49. Excellent. You're really on the right track. What other dimension can I have? Did everybody understand this part?
Yes, yes.
So first 2 rows, I can create 7 2 by 2 squares. Next 2 rows, I can create another 7 2 by 2 squares. Next 2 and so on. But how many such rows are possible? So if I look at it horizontally, there are 7 such strips possible. And each of those strips will give me 7 squares. So it is 7 into 7, 49. What about 3 by 3?
Ma'am, 36.
Oh, is that a guess? Or did you actually?
Actually, from the pattern, we can see that.
What's the pattern?
If there's a pattern, because we have 8 square, 64, 7 square, 49, now 6 square, 36.
While using your pattern thing. Very good. Yeah, so you can actually check that if you see a 3 by 3, now we look at first 3 strips. How many 3 by 3 squares will there be? There will be 1, there will be 2, there will be 3, 4, 5, and 6. 6 this way and 6 this way. So 6 into 6, there will be 36. And now rest you will not want to count because now you are clearly seeing a pattern. So what should be the next 4 by 4?
25.
25.
5 by 5, all the way up to
60.
Very good. 6 by 6.
9.
9.
7 by 7.
2, 4.
4.
4. And 8 by 8, we already said there is 1. There is only one single 8 by 8, one single chessboard. 7 by 7, there are 4 of them. How? Which are these 4 squares? Can you point them out to me?
Yes, ma'am, there are 4.
Which are those 4? I know it's hard for you to explain when you can't, but then you can just try and describe it to me.
Okay, I know how to do it, but I'm not sure how to explain.
Go ahead, no problem.
Okay, from the top left corner, 7 blocks down.
Okay, 7 blocks down.
Yeah, but you make a 7 by 7 square, you'll get it easily.
So from this corner, you can make a 7 by 7 square.
Yes, you can make a 7 by 7 square.
And you can just make a 7 by 7 square from every corner.
And then move it one column away. We can overlap.
Yeah. So with this corner, this is the 7 by 7. If I start from this corner, I would go up to here.
Yes.
Every corner is 1 7 by 7 square, and clearly there are 4. Very good. And there is 1 8 by 8. So what is the total number? In fact, if I were to ask you that instead of an 8 by 8, if I had an n by n chessboard, I'm generalizing it now, right? Then what would be the total number of possible squares of all dimensions?
We take out the n factorial.
Okay, 8 by 8 के लिए क्या है answer? Total number of squares is 64 plus 49 plus 36, right? Adding up all these numbers. Basically, for an 8 by 8, what is the answer?
Is it 204?
Very good. This is the answer, right? Is this the answer?
Yes, yes, this is the answer.
And this total sum you have calculated is how much?
I think it's 204.
204.
Anyway, that number is not so important. But the fact that we can say that on 8 by 8 chessboard, the total number of possible squares of all possible dimensions is 1 square plus 2 square plus 3 square all the way up to 8 square. The sum of the squares of the first 8 natural numbers. Right? So if it was a 10 by 10 chessboard, what would the answer have been? I mean, I don't want the final answer, but you can tell me the
10 square plus 9 square plus 8 square plus 7 square.
the sum of the squares of the first 10 natural numbers.
Yes.
And if it was an n by n chessboard, it would be? Okay, for 8 by 8 chessboard, it is 1 square, 2 square, up to 8 square. For 10 by 10, it would be 1 square, 2 square, 3 square, up to 10 square. So for n by n chessboard, it should be?
From 1 square till n square.
Till?
N square.
N square, fantastic. See, you've generalized the problem. So this 1 square plus 2, the squares of the first n natural numbers, that would be the total number of squares of a n by n, if it was whatever your value of n may be. Okay, now we're using the variable n, and this would be the summation. For mathematical convenience, we use this. Are you familiar with this notation? Okay, so this is called sigma. Sigma means summation of. So let me take you to the, so this symbol is called sigma. So how, instead of writing every time 1 square plus 2 square plus 3 square all the way up to n square, I can write this. One of the ways of writing this is, I can say this is sigma k square, where k goes from 1 to n. Okay. This essentially means that instead of k, first I put 1. So I'll write 1 square plus. Instead of k, I put 2 because k varies from 1 to n. So I put k as 2, so it will become 2 square. Then I put k as 3, it will become 3 square. All the way up to last value of k is n. So if I put k as n, it will become n square. Don't worry about this. If you're not comfortable, it's fine. But this is, I'm just telling you, in mathematics is also about writing your symbols in a manner so that writing is convenient. Okay. So this is just another way of representing this notation: 1 square plus 2 square plus 3 square plus n square. But the fact is, this is the total number of squares on this chessboard. I mean, if it were an n by n chessboard. So if there were n squares on this way and n squares down this way, total now, whatever your value of n may be. Now you know the answer, right? So for example, if someone says, hey, look, if I have a 20 by 20 chessboard, can you tell me how many squares there are on this chessboard? You'll say, yeah, I know. You'll say it is 1 square plus 2 square all the way up to 20 square. Of course, there's a formula for this also, which tells us exactly what the answer is. But that is something that we will maybe do later on. Okay, so now I wanted to, so 204 is your answer for the 8 by 8 chessboard. Is that okay? Before we proceed, so what is the second question? First question was, how many squares of all possible dimensions are there on an 8 by 8 chessboard? Your answer is 204, which is equal to 1 square plus 2 square plus 3 square all the way up to 8 squares. This is your final answer. But you know, it doesn't matter really. I mean, we are not always, the aim of mathematics is not to always arrive at the one right answer which is behind the textbook. No. It is about exploring the problem, seeing patterns within the problem, and trying to get an insight into the problem, because that insight may help you to solve other problems, right? Now, the insight that you have obtained while playing with part 1, question number 1, will also kind of help you to address question number 2, which now asks a more general question. How many rectangles of all possible dimensions are there on this chessboard? Okay. Why is this a more general question? Why is 2 more general than 1? What is so specific about 1 and what is so general about 2? Can somebody comment on that?
Ma'am, can you repeat?
Pardon me?
Can you just repeat the question?
So we are saying that, see, question 1 is asking how many squares of all possible dimensions are there on this chessboard, right? We've answered that question, and whatever we calculated, and we got 204. We saw certain patterns and all. Now the second question is asking how many rectangles of all possible dimensions are there on this chessboard. And I'm saying 2 is a more general question than 1. Why is that? Why am I saying that? Am I correct or?
Ma'am, because in 1 it is specified that we are supposed to look for squares, whereas in the second one we can look for squares and rectangles. So basically quadrilaterals.
Very good, very good. So, so rectangles are more general than squares, because that's the only difference between these two questions, no? The word squares has been replaced by rectangles. But why is rectangle more general than a square? Is a square a rectangle?
Yes.
Okay, let me reiterate that.
A square is a rectangle.
Square a rectangle?
Yes.
But is every rectangle a square?
No.
No. So rectangles are more general, quadrilaterals. So every square is a rectangle, but every rectangle is obviously not a square. So that is why this is the more general question. Now we have to figure out a way of counting. Of course, rectangles will include squares, right? We've already counted that there are 204 possible squares on this chessboard. Now we want to count the rectangles, total number of rectangles. Okay. Now we have to come up with a strategy. Can you tell me what will be the dimensions here of the rectangles? Kya dimensions? Can somebody name some of those dimensions?
I'm like 1 by 2, 1 by 3, 1 by 4.
1 by 2, 1 by 3, okay, 1 by 4, all the way up to 1 by 8. What's a 1 by 8 rectangle here?
Ma'am,
either one row or column.
One strip, right?
Yes.
Okay. 1 by 2 is simply this. Or maybe this, right? Or maybe this. Or maybe this.
Yes.
Okay. Now, so, okay. So what about 2 by 1? What's a 2 by 1?
Ma'am, it's the same thing.
Okay. Is there a difference between a 1 by 2? Would you like to make a difference between 1 by 2 and 2 by 1?
Okay, we can make it vertical instead of horizontal.
Yes, very good. So this we can treat as a 2 by 1. Obviously, it's different from a 1 by 2. Right?
Yes.
Okay. Great. So we have, you have given me so many dimensions, 1 by 2 all the way up to 1 by, then you can have 2 by 1, 2 by 2. Of course, I have 1 by 1 also, which is a square, but it is also a rectangle. I have 2 by 1, then 2 by 2, 2 by 3, all the way up to 2 by 8. Right? Then I can have 3 by 1, 3 by 2, all the way up. Can you give me a 3 by 2 rectangle? Can I draw a 3 by 2 rectangle on this grid? 3 rows and 2 columns. So let us say when I say m cross n, m represents a number of rows and let's say n represents the number of columns. So if I say 3 by 2, I would need 3 rows and 2 columns. So maybe this. This is a 3 by 2. Whereas a 2 by 3 would be this. 2 rows and 3 columns. So you know the difference, no? You understand. So the
Yes,
first
yes,
number tells us the number of rows and the second number tells us the number of columns. That's fine. So how many such dimensions can we have? Because now the problem is more general. So obviously we have more things to count. And we want a more convenient way of counting that. Any ideas? अच्छा ये बताओ कितने dimensions हैं हमारे पास? How many possible? So I start with 1 by 1, I go all the way up to 1 by 8. Then I have 2 by 1, then up to 2. Till what do I have?
Ma'am, but we needn't include 1 by 1 and 2 by 2 as they are squares and they were already included in the...
Let it be. Well, we can't leave out the squares. We know that. We know that the total number of squares was 204, but we still have to include them. Obviously, the answer to this question would be including those 204 squares. So what is the largest dimension you can think of for a rectangle?
If we don't consider squares, that is 8 by 8, then we'll have 8 by 7.
8 by 8 को consider करेंगे. We started with 1 by 1. So we will go all the way up to 8 by 8. And of course, we are conscious of the fact that 2 by 2 is also included, 3 by 3 is also included, and so on, right? Okay. So let me tell you, let me suggest a way. I need to count all these dimensions, but you know, like in the case of squares, I quickly wrote down 1 by 1, 2 by 2, 3 by 3, up to 8 by 8, and I could easily, you know, write. But now I need a more convenient way of representing this. Okay. So any thoughts how I can make a table so that I can quickly count? So let me try. See, what if I write the numbers here? 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. After this problem, I'm thinking we'll take a short break.
Yes, ma'am. We'll take a break for half an hour or so. Yeah.
Yeah, sure. I thought it was 11 to 11:30, but we can take it earlier, no problem, because we don't want people to tire out.
Yeah.
So I've written 1 to 8 here and 1 to 8 here. Okay. Why have I done that? I want to count the number of, let's say I want to count the number of 1 by 2 rectangles. How many 1 by 2 rectangles are there? Can somebody answer that question? 1 by 2 rectangles. 1 by 2 क्या है? ये यहाँ से शुरू करो. This much. And how many such are there on the first row?
7.
7.
7. Wonderful. So there's 7 such 1 by 2 rectangles. Which are those? 1, then 2, then 3, 4, 5, 6, and 7, right? And how many such from each strip? There'll be 7 from each strip, but how many strips are there? Is the question clear? From the first row of the chessboard, I got 7 1 by 2 rectangles. So totally, how many will I get?
Ma'am, 49.
But there are how many such strips are there?
Ma'am, you'll get 56 as there are 8
Yes.
columns. So like
If there are 7 for each column, then that will be 56.
So there are 8 rows, no? Each row will give rise to 7 such rectangles. So it will be 8 into 7, 56. Is it clear to everyone? First row is giving me 7. Second row will give me 7, third, fourth, fifth, sixth, all the way up to 8. So 8 rows, each giving me 7 rectangles. So 8 into 7 it will be. So 1 by 2 rectangles will be 56. So I'm writing it like this so that it helps you have to fill up this grid for me. Because you won't need to fill up. अच्छा 2 by 1 क्या कितने होंगे? 2 by 1 will be this way. But do we really need to count all of them?
For every column we will have 7.
हाँ, so कितने होंगे 2 by 1?
56 again.
Again 56. We don't need to count. With symmetry, I can write the answer. Am I right?
Yes.
So if I know 1 by 2, I automatically know 2 by 1 also. Of course, 1 by 1, we had already known it is 64. If I fill up the first row, you will see a pattern. And then you will automatically fill up the first column. Something very interesting about filling up this table. Now let's look at 1 by 3. How many 1 by 3 rectangles are there? Take any row. Let's take this row. Take this row. This is a 1 by 3. Second.
And we have 6.
6 on this, right?
Yes.
Total कितने होंगे?
48.
6 into 8, 48. So 1 by 3 is 48. So 3 by 1 will also be 48. Now quickly, can you tell me 1 by 4? Do we need to count or do you see a pattern?
40.
40. Why?
We're subtracting 8 as we go.
Ah.
They're
Next.
multiples of 8.
Multiples.
8 by 8.
So
8 by 7, 8 by 6, 8 by 5, 8 by 4, 8 by 3, 8 by 2, 8 by 1.
Next will be
32.
32.
24.
24.
16. 8.
16. 8.
And I can just quickly write down the same numbers here. Sorry, this is 40. I don't have an eraser. 32. 24, 16, 8. Wonderful. Now let's come to 2 by 2. We already know. Now there were 49. We had square. These are squares, so we had counted them. What about 2 by 3? Let's just do this one thing. 2 by 3 ke bata do. So let's look at the last two strips. Let me just for your, if you want to check. Let's see. Last two rows, this is a 2 by 3, right? So how many such 2 by 3 rectangles can I find in the last two strips, in the last, this much?
6.
6, okay. And how many overall? So this is 1, this is 2.
Ma'am, there are 42.
Very good, wonderful. So there are 6 from here, and if there are 7 such strips we can create, so 7 into 6 is 42, wonderful. Okay, now we are doing in blue, doesn't matter. So 3 by 2, 2 by 3, 42 hai, to 3 by 2 bhi 42 hoga. By symmetry I can write down. Can you complete the second row?
Yes, ma'am.
These are the?
Ma'am, multiples of 7.
Wonderful. तो आगे बता दो जल्दी से क्या आएगा इधर?
Ma'am, 28.
42.
Ma'am, 35. 35, then 28.
35.
28. 21.
14.
14 and 7.
Now I think you've solved the problem. See, ultimately, what do we want to do? We want to fill up this table, the sum of all the numbers in this table. Sum of all the numbers in this table will give us the total number of rectangles on this chessboard. Now you will say, oh God, that will be too long. It won't be actually. You will quickly see that there is a pattern. You've already seen the pattern. Dekho, yahan pe multiples of 7 hai. तो ये भी
next one there are multiples of 6. And the next line there are multiple of 5.
But can you quickly complete the second column for me?
Yes, ma'am. 35, 28, 21, 14, 7.
Wonderful. 7. Okay. Again, you said these should be multiples of 6. So can we say 42 के बाद क्या आएगा?
42,
36,
36,
Like
30,
diagonal of square numbers.
18, 12,
24,
6.
18, 12, 6.
And similarly 30,
24, 18, 12, 6.
Very good. So we can complete the rest, no? So I know these will be multiples of 5, then 4, then 3, then 2, and then 1. All of you agree?
Yes, ma'am. Yes,
Last वाला row क्या होगा? सबसे
Ma'am, 7, 6, 5, 4, 3, 2, 1.
They're multiples of 1, so it's simple enough.
Now you have to tell me the sum of all these numbers inside the table, not these outer ones, huh? Only inside the table. I hope you're not saying, ma'am, to हमें addition करने को कह रही है. Okay, let's look at the last row. What is the sum of 1 to 8? I'll switch back to red.
36.
6, 10, 10, 5, 15, 15.
36?
6.
Yes, 36.
Okay, the sum of the last row is 36. All of you agree with me?
Yes, ma'am.
By the way, do you know that story about Gauss, the great mathematician Carl Friedrich? So when he was a very small child, in the class, you know, all the boys were making a lot, they were all boys in that class. And they were making a lot of noise, and the teacher, maths teacher, was sitting and getting angry. And Gauss was the one, the most restless. And he said, let me try to keep this child quiet. And so he said, come, and he comes to his table and say, you sit and add up all the numbers from 1 to 100. Okay. And sit and add them, and when you find the answer, you come and tell me. So he looked at the teacher. In 1 second, he told the answer. The teacher was completely amazed. Very small child. So what do you think he did? He was asked to add numbers 1, 2, 3, 4, all the way up to 98 plus 99 plus 100, right? He was asked to find the sum. Teacher thought he will take a lot of time and he will spend the time, he'll sit quietly. But obviously he didn't, because he just told the answer in one go. What do you think he did? So what he did was, do you know the answer? Don't add. I'm not asking you to add. Okay, if you had to actually add up 1 to 100, again, is
it is 10,201.
Right? Okay, let's see. How did you arrive at that answer?
Ma'am, I added the first and the last number and the square of that number.
Oh, you squared it. But what is the sum of the first and the last?
Ma'am, 101.
101, yes. 1 to 100 is 101. But what about 2 and 99? What is that sum?
That's also 101.
101.
And what is 3 and 98?
They're all 100.
So how many such pairs are there?
Ma'am, 10.
50.
10.
50. 50.
Yeah. So 50 pairs, each adding up to 101. How much is that?
5,050.
Yes. 5,050. 50, yes. That's exactly what he did. So If you have to sum up numbers from 1 to n, what is the actual thing? So basically, what is it? How did he get 5050? He said 101 is the sum. And there are 50 numbers, right? 50 pairs, which is 100 upon 2. So if you have to sum all the way from 1 to n, what would you do? You would divide the total number of numbers by 2, because 50 is 100 upon 2, right? And multiply it with the number next to n, which is n plus 1. Does that make sense? 1 to 100 का आंसर कैसे आया? It was 100 upon 2, which is 50, multiplied by the sum of 1 and 100, isn't it? यही किया ना आपने?
Yes.
Yes, ma'am.
So instead of 100, if there was n, what would you do? You would do n upon 2 into n plus 1.
Yes.
And this is the formula for the sum of any n natural number starting from 1. So that way also, if you see, if I have to add up 1 to 8, what will I do? I will simply say 1 to 8 agar add karna hai. So I will say the last number n is 8, right? So n by 2, which is 4, n by 2 into n plus 1. This is what I'm going to use. N ke jagah pe I'm going to put 8. So it is 4 into 9. N plus 1 is 9. 9 into 4, 36. That, see, 1 to 8 is very easy to add. You've already told me it's 36. But suppose it's 1 to, say, 500, or 1 to 498, or 1 to 10,250. What is the sum of 1 to 10,250? You are not going to sit and add them up, right? So this formula works. Just put the value of n, divide by 2, and multiply by n plus 1. Okay, that's just, these are things you will learn in class 11 and how to derive and so on. Anyway, let's quickly come back to the problem because you are almost at the answer. So you told me that the last row is adding up to 36. Please note that I am not counting these. These are just not to be counted. Only the numbers inside the table. 36. But what about this row? This row will have what? 16, 14, 12. Aage kya aayega idhar? What are the numbers here?
10, 8.
10, 8, 6,
4.
6, 4, 2.
Without actually adding them up, can you tell me what they will give me? Knowing that 1 to 8 ka sum is 36. I mean, of course you can add them up, but without adding, is it possible to know?
I added them first and then I'm seeing a pattern. It's
Tell
72.
me that pattern, yes.
Sum is 72 and it's 36 times 2.
36 times 2, yes. Because each of these numbers are double of these, right? So agar iska sum 36 hai, to iska twice of 36 hoga. So this will be 2 into 36, right?
Then you'll get on the row above that 144, then 288.
Yes. Then the numbers, just tell me the pattern. Next, isme kya aega?
3, sir. 3, sir.
3 times 36.
So 108.
I'm not writing the numbers, but you know they are there, right?
Yes.
With this row, these are multiples of 4. So what will we get here?
144. Wait, yeah.
4 times 36?
Yes.
Very good. All the way up to?
8 times.
8 times 36.
Very good. So I have 8. Sorry, my stylus starts. This is 8 times 36, 7 times 36, 6 times 36. Why am I writing it like this? Why am I not calculating like you? Because I have to add these up. So this last one is 1 times 36. 1 times 36, 2 times 36, 3 times 36, all the way up to 8 times 36. Is that easy to add? 36 तो common है. चलो यहाँ लिखते हैं. 36, I have to add these up.
And the answer is 1296, right?
How did you get it?
Mama, I added the numbers like 1, 2, 3, 4.
How did you add it? That's what I'm asking.
It was given like 36.
So couldn't we take 36 common?
Yes, ma'am, I did that only.
And
first I added the numbers from 1 to 8, ma'am, which is 36. And ma'am, then 36 into 36.
36 square is 1296.
So that is the answer. Of course, this 1296 includes those 204. Because see, this table includes this diagonal also. Now, what is the diagonal?
Square numbers.
Square numbers, but these are the number of squares on the chessboard. We had already counted them in the first 64, 49, 36, 25, and so on, right? Okay, so wonderful. So we have now figured out the answer, but one more, we should take a break now. It's almost 10:30, so half an hour break. But before that, when you come back, when we meet after half an hour, you have to tell me that on an 8x8 chessboard, the 1296 hai. Okay? 1296 is the total number of possible rectangles on an 8x8 chessboard. But what if it was an n by n chessboard? After all, we are mathematicians. We want to always generalize a problem. We don't want to just look at a specific case. For squares, we have already solved that, isn't it? So for squares, we had said that, just a second. Yeah. For squares, we had said that for an n by n square chessboard, the number of squares would be 1 square plus 2 square all the way up to n square, right? And there is a formula for that in terms of n, but I haven't told you that. But if it was an n by n chessboard, how many rectangles would there be? For 8x8 chessboard, the number of squares we know is 204. And for an 8x8 chessboard, the number of rectangles is 1296. This you have already solved. But for the more general case, suppose this had n squares this way and n squares this way. What would be the total number of rectangles? Okay, so that is the answer. I mean, if we get it, fine. If not, it's okay. We'll continue with other problems. So should we meet back at 11 o'clock, ma'am? Is it okay?
Yeah, ma'am. 11 o'clock. Same channel, and same link. Yes, ma'am.
So should I close right now? And I think that
we rejoin.
Yes,
that would be fine, ma'am. Yes.
Okay. Okay.
Thank
you. Thanks a lot, and see you soon again.
Yes.
Thank you, ma'am.
Okay. Bye.
Thank you, ma'am.
So I'll just. Should I end the meeting then, right?
Yes, ma'am. Yes.
Okay. See you then. Bye.
Bye.